Hello everyone, welcome back to class 12 computer science series. In this video, we will learn one important concept of computer science Python series, that is chapter number 3, Stack Data Structures. So let us start chapter number 3, Stack. This is our today's chapter. So what we will learn in today's video, let us enlist them first and then we will start one by one. First, we will understand what is stack. Our first point will be what is stack. Then we will understand how does it works. Okay. In the next point, we will understand why this is called LIFO data structure. Why stack is LIFO data structure. Okay. And the next point, we will understand the real life example of stack. And at last, we will understand two important operations, push and pop. So what are push and pop operations? So these are the points we will cover in today's video. So let us start one by one. So let's get started. So our first point is what is stack? We will explain by the diagram so that data structure will be explained easily. First of all, any data structure we have in our memory have some structural status, like whether it will be graphical or hierarchical or tree structure or linear. So among this only one structure we have to choose and accordingly we take it for our use. When we have to choose a stack, we have to keep in mind the structure is like this. Means we can assume it as the array structure. Array means what? The continuous blocks will be there with a separation. So this is called contiguous structure. Contiguous means small blockages are there, but the things are arranged sequentially. So these blocks are the separations. Like when we take a rope, this is a continuous structure. But when we find a knots between the rope, it is a contiguous structure. So this is how we can differentiate between continuous and contiguous. Here we can see, yes, it is continuous, but again separations like knots are there in between the data structure. So that is why this is also contiguous. Now in this data structure, how the elements will be inserted, that needs to be understood. First of all, the first element will go in the first block. Suppose A is the first element will be placed. Then the next element will be placed after the first element placed. Then this is the place after the first element, the next element placed here. Then after that, the next element, and after that, the next element. This is how the series goes on. Means we have to start from the bottom and we have to go like this, bottom to top. And when we have end up to the last element will now not allow any elements and will not allow the replacement of any element. Okay, replacement will be done only and only when we delete the element. Now the question is there, if we need to delete this element from the second place, means the B should be deleted and any other element wants to come in place of B. Whether this is possible or not in this data structure. Clearly we can see that up to D it is blocked. No path is there to reach up to B. So what to be done? First D will be removed. Then C will be removed. And then the B will be removed. After that the B's place will be empty. This is how this stack works. It means what? We can conclude that this is our stack. Insertion will be done like this from the bottom, and when we reach up to the top and our insertion will be closed, whenever we require deletion, the first element removed will be the top element. This is our top element. Okay. So first top element will be removed. Until and unless top element will not be removed, the next and next elements will not be removed. This is how it works. Stack structure, and we can clearly see this is a linear structure. No hierarchy, no tree, no graph is there. So first of all, this is a linear data structure. By the diagram only we can visualize this is a linear data structure. And one more thing we can conclude from the diagram, that whenever the last element will be placed over here and during the time of removal, the last element placed just recently only, but still it will be removed first. It is placed recently only, but regardless of that, when we have to remove the element, the last element only will be removed. D will be only removed first. This is means what? The top element will be removed first, and then continuously the elements will be removed up to our desired location. So this is how the deducel is done. Means what? We conclude that the last entered element will be thrown or will be fetched first of all. Means last int will be very first out. That is why this is called LIFO structure. This abbreviation is for this form. Last in, first out. Means last inserted element will be removed. This we have to do because the structure is like this only. Last element will be removed, then only the path for the next element will be opened. We can reach up to our desired location, and continuously after the top element, the next element will be removed. D, then C, then B, and then only A. This is how we delete. This is the main principle of this stack structure, that the last element will be removed first. Okay, we have seen the structure. Now the part is how this structure works in real life. The very common example we will see. I'm sharing the screen with you, and you see how this LIFO structure every day we are using. This is the real life application. Okay, suppose we have opened this browser. The Edge browser is installed over here. Now we are opening this. After opening, suppose we have to go to the Google. Now we are typing www.google.co.in. Okay, we have reached on the Google page. This is our interface for the Google. Here we are typing Wikipedia. After Wikipedia, the links are available over for the first page only we will choose, and then we reached up to the Wikipedia interface. Now on the Wikipedia, type some term. Now we have to find energy, definition of energy, and regarding the energy, whatever Wikipedia contains, we need to see. So after typing the energy, we have reached up to this page. Now continuously we have given the inputs. First Google, then inside that Wikipedia, then links came, then Wikipedia came, then we have given a term energy, and we reached up to here. Now we have to go back from the same path. Okay, if we want, we can definitely we can press the next tab and we can go again the next search. But now we want to go, now only we want to go from the same path we came across. What to do? This back button we will press, and this page will be removed first. It means what? The recent page will be removed first. It means what? The top element in the stack will be removed. See here, removed. It was a recent search. Now again press the next recent, next, and we came up to our first element, that was our browser. So this is the best example every day we are using. Here is the implementation of stack. If we are pressing back button again and again, the topmost element, then the next element after the top, and then the next. This is how the removal is done in this stack operation. One more example we can see is the MS Word example, where we can type something and Control Z we are pressing. The last element is removed. Whenever means last element is removed means what? The last element inserted was removed from the memory. This is the structure of the LIFO. So this is how stack implementations are there in our computer only, and we can see very easily lot many examples are there. And from the real life, we can take the plates example. Dining plates are there in the party, and the last inserted place will be removed very first. And this is how we remove the plates. From the bottom, we are not fetching other plates, obviously. Na? This is how LIFO works in our real life. And in the context of computer, we have seen the examples. So we have seen the real life example. So let us conclude up to this what we have done. First of all, we have seen what is stack. So stack means what? So basically you can tell it a data structure. What type of data structure is this? Linear data structure. Okay. In 1 marks question, you can write this definition. It's a linear data structure where insertion as well as deletion, okay, both the operations done from the top. And this is why we can call it LIFO data structure. So up to this, it is clear, I think. It is a linear data structure where insertion and deletion done from the top. And this is why we call it last in, first out data structures. And we can make it the diagram of the simple array structure, means this diagram also we can make it. Okay. And the last element, you notate it by top. This is how we can write the 2 or 3 marks question about the stack. Okay. We'll move forward towards push and pop. That was our last point. So first of all, we will see what is push operation in stack. The implementation of push we will see in the later videos. Now only we will see the introduction what is push. Push operation. First of all, we have a stack over here, and this is the stack. Linear data structure stack is drawn over here, and these are the places where we will insert the elements. First of all, A is the main element which is to be inserted. So where it will be inserted? Here, not here, not here. It will be inserted in the very first position here. The first position from the bottom, and then it becomes the topmost element because no more elements are over there. Now the next element B is coming over here. Okay. So this place, we will place B. B is coming over here and B will be placed. Now B becomes the top element. Okay. Again, this placed is empty now. The next element wants to come, that is C. C wants to come. Then what to do? This place will be now filled with the C, and the C will be the top element. So this is how the insertion takes place. The element recently placed in the stack is called the top element, main top element. If no further elements are over there on the above, that is the last element inserted is called the top element. So this is how insertion takes place in the push operation, and this insertion is only called push operation in stack, means inserting the elements, nothing else. When we insert the element, it should be from the bottom, and the topmost element will be removed first when we have to delete it. So now we move towards the deletion operation, how it will be performed. Deletion means pop. Pop means only deletion will be performed on this stack. Popping. First of all, the stack is over here, elements are already sitting inside this. First element to be popped will be the top element. First of all, C will be removed, then B will be removed, then A will be removed. Now the stack will be empty. Everything is removed now. All of the 3 places are empty now. This is called popping or deletion of the elements. Here 2 situations are coming. We can see the 2 situations, one inside the insertion operation and second inside the deletion operation. The 2 terms are coming in the examination, underflow and overflow. So let us see this by an example. What is underflow and what is overflow? So suppose this is the stack, and element A, B and C is there in the stack. This is the topmost element in the stack, and this stack is full. There are no more places above the C. Now someone wants to insert over here. Is this possible? No, this stack size was only 3 and all the three are filled already. No more insertion can be done without deletion. If you want to delete it, then only the next element will be insertion. Otherwise, no other option is there to insert any element if it is full. So this situation is called stack overflow. If we want to insert any element, suppose D is there sitting and waiting to come inside this same stack and want to try to be inserted in the same stack, it is not possible because D is outside element and the stack size is only 3, that is already full. So during the insertion, when stack is already full and next element wants to come, this is called stack overflow, and this situation occurs during the post operation, because during the insertion only we can face this. So this is called stack overflow. Next is called stack underflow. We'll see by the example. Let us draw one more array, that is a stack array. This is our stack. Here no elements are over there, actually it's empty. So let us make it empty. Nothing is there inside, but places are there only. Means elements can come, they can sit, but already if we see, nothing is there. It's empty. So if we want pop operation in this empty stack, what to be deleted? Nothing is there. So when we find a situation where deletion is not possible just because nothing is there to delete, this is called stack underflow. Underflow means what? It's empty, and this empty situation, underflow situation, will create a problem if we want to pop something from the stack which is empty. So that is called stack underflow, and this occurs when we are deleting or popping the element from the stack. So this was called the stack underflow and overflow. Two terms are coming in 1 marks. You may answer it very easily. So this is how we covered these points, all the points in this video. What is a stack? We know it's a linear data structure and where we can store the elements. Insertion and deletion can be done from the top, and that's because we are doing everything from the top. Last element is a prior element. Last element will be deleted first. If it is placed in the last or just recently placed, then also it will be removed first. This is why it is called LIFO data structure. How does it works? We know from the top it works all the time, and insertion will be from bottom to up and deletion will be from the top. Okay. Real life example we have seen, our browsing. When we browse one by one, pages will come back, the pages will be removed, same like stack structure. And Windows, we can see if we do Control Z, the last recently used element or memory will be removed first. And push and pop we have seen, and inside that push and pop we have seen underflow and overflow also. In the next video we will see how to implement this stack, and uh, in the Python, we will do the programming of stack also, and using the Python program, how to do the programming. So this was the video. Introduction part only is there in this video. And if you found this video beautiful, sorry, if you found this video useful, do like, share and subscribe. And thank you for watching. See you in the next video.